Hey there, and welcome back to another Papetti Math YouTube video tutorial where I'm going to be showing you, yes, you, all the different parts of Algebra 1. That was different than the other videos. Did I throw you off? Okay. Anyway, this is exercise number 6, where we're going to be looking at something else that could happen to absolute value functions. And if you recall from exercises numbers 2 through 5, we looked at what makes an absolute value shift to the left, to the right, up, and down. But absolute value graphs can be transformed in other ways as well. Here you will look at how you can make an absolute value function narrower or wider. So in exercise number 6, it says to graph p of x equals 2 times absolute value of x. So let's start off like we did with all the others, and let's make a table. And in our table, we'll use our standard -3, -2, -1, 0, 1, 2, 3 x values. And then to get our p of x values, we want to substitute this x value in for the x up there. So the absolute value of -3 is +3 times 2 will give us 6. The absolute value of -2 is +2 times 2 will give us 4. The absolute value of -1 is +1 times 2 will give us 2. The absolute value of 0 is 0 times 2 is 0. The absolute value of +1 is +1 times 2, which is 2, and there you start to see your y values repeating. Okay, 2 times 2 will give you 4, and the absolute value of 3 times 2 will give you 6. So yes, again, there you have your y values repeating, and we are going to graph these on this grid right here. So let's graph the point -3, 1, 2, 3, 4, 5, 6, -2, 1, 2, 3, 4, -1, 2, 0, 0, 1, 2, 2, 4, and 3, 6. So there we have a V. It looks a little bit different, and we'll talk about how it looks different in a minute. But first, let's connect those points with a nice straight line. Look at that V right there. There we go. And arrows on the end to show that that goes on forever. And if we were to graph our parent function on this graph, and you don't need to do this, you could just take a look at this one. Our parent function looked like this right here. And now we want to notice how the function p of x is different from the parent function f of x right here. Is it narrower or is it wider? And you might see that those two lines of the v went from like this to like that, from this to that. So that would make it narrower. So we want to say that the graph of p of x is narrower than the graph of f of x. And again, that's probably because we increased this number outside the absolute value. We multiplied by a number larger than 1, which happened to also change its slope. If we're looking at slope, the slope is now up 2 units over 1. And that over is either in a up to right 1 or up to left 1, depending on which side of the absolute value you're on. But this number is directly related to the slope of the absolute value, or the rate of change for that matter. If this video is helpful in seeing how you make a absolute value function narrower, give it a thumbs up, and you're now ready for exercise number 7, where we're going to look at how it makes it wider. Thank you for watching.